Today we're going to look at Chapter 8, Section 1. We're finding angle measures in polygons. So you're going to learn today what a polygon is. We're going to talk about interior angles. We're going to talk about exterior angles, and we're going to find some of those measures. All right? So first of all, let's take a look at the definition that is a polygon. Okay? A polygon is a closed plane figure with at least 3 sides. And you go, oh my gosh, I have no idea what she's talking about. Okay, let's take a look at it. First of all, it's a closed plane figure. This is what it means. If I have the figure, okay, it's going to be closed. Do you see how this is not closed? Like I can put something in it. Okay, so this is not closed. So it needs to be closed, like I'm not going to put something inside of it. This might be something you write down on your notes because this will be in an assignment. It will also be in an assessment. So you're like, what does closed mean? Okay. It also needs to have all straight sides. So this is not because it's not straight. It's curvy. Okay, again, I would write this down for your notes. So it has to be a closed plane figure, and it's going to have more than 3 sides because if it only had 2 sides, do you see how it's open? I mean, that doesn't make sense. Okay. So, naming it. You can start at any vertice. I'm going to start at N. And I can go clockwise or I can go counterclockwise. And you need to name all the vertices because that also tells you how many vertices are in the figure. It also tells you how many sides are in the figure. So an example would be, okay, I'm going to pick N and I'm going to go clockwise. So N, M, Y, T, L, and W. They are all capital letters. There are 6 of them. That means it has 6 vertices and has 6 sides. Or I could pick N, and I can go counterclockwise. So I can go W, L, T, Y, M. Now I'm going to change my color. I'm going to tell you what not to do. So you don't name it this way. So like I got an N, and I'm going to skip all over. I'm going to go N and I'm going to go T, W, M, L. I don't do that, okay? So I'm not going to go N, T, L, Y, M, W. I'm not going to do that. They can't skip all over. They have to either go clockwise or they have to go counterclockwise. You can start at any vertice. Questions? Am I going too fast? If I go too fast, please tell me, because otherwise I don't know. Just like, whoa, slow up a minute. All right. Now, concave and convex. Concave is like you have a little shape and someone blows into it and it goes out. All the vertices are pointing out. Okay, that's convex. Concave is where it's caved in. It's like someone went up to it and went, donk, and it's like dented. That is on your test. The difference between concave and convex. I will have 6 shapes, and you will have to list them as you go. So it will be on your assessment. Questions? Okay, let's keep going. All right, so I'm going to look at a polygon name and the number of sides. So a 3-sided figure is called a triangle. Yeah. Okay, and you go, well, duh, Mrs. Medvik. I've had people call it a triagon. They think it's a polygon, so it's got to have a gon on the end. Don't do that. It's a triangle, okay? 4-sided figure. Quadrilateral. Now I'm going to stop for a minute. when I ask for a three-sided figure, sometimes kids will say obtuse triangle, acute triangle, equilateral triangle. Those are all types of triangles. So polygon is like an umbrella. Underneath that umbrella, you've got a triangle. Underneath that, you have all the different types. Same thing goes with a quadrilateral. You've got a part that comes out of that umbrella that's a quadrilateral. Then underneath that comes your rectangle, your square, your trapezoid, your rhombus. That stems from the quadrilateral. Quadrilateral is the broad name of all those shapes. Okay. Five-sided figure is a pentagon. Think of Washington, D.C. The Pentagon, how many sides does it have? 5. They were creative when they made that name. I think let's call it the Pentagon because it has 5 sides. Six-sided figure. Hexagon. Seven-sided. A lot of people think septagon because septuplets, right? It's not true. It's a heptagon. Yeah, it is. It's a heptagon. Yeah, very good. And don't feel funny, oh, I thought it was a septagon. Don't. That is a very common mistake. So don't get caught on that, okay? It is a heptagon. An eight-sided figure is a octagon. I would hope you would know that, right? Like an octopus. Nine-sided. Yeah. Nonagon. It is a nonagon. Mm-hmm. Yes. Decagon. It is a decagon. Think decade, right? Yeah. Dodecagon. It is a dodecagon. Do meaning two, and then decagon. And then this last one is n-gon, and you go, why? Like, why would you say n-gon? It'll be in the directions of the following n-gons. All that means is that we're going to be using a polygon. Now, couple of things. Let's look at this list. What ones do you feel students trip up on most of the time with naming? The number one problem when naming. Which one do they mess up on? Yeah. 7. Yeah, 7. Yeah, it's the heptagon. Students have trouble with this one. Okay, so I don't know if you want to star it. You will have it on your test. Another one that they struggle with is nonagon. For some weird reason, just can't remember it. And then dodecagon is another one that they struggle with. Now, there are other names. If you looked them up, you could find them. These are the general ones that people just know. Okay. Questions? All right, let's keep going. So here's kind of a definition. The sum of the measures of the interior angles of an n-gon is, okay, and you go, what the heck is that? So if I have a pentagon, or if I have an octagon, or if I have a decagon, I want to find out how many degrees, if I add up all those angles, how many degrees would it be? It's always the same for any pentagon. Whether the pentagon has a right angle in it or has an obtuse angle, it will still have the same number of degrees. Same with the decagon. Or think of a triangle. If I have a right angle in it, or an obtuse angle in it, or an acute angle in it, how many degrees is a triangle? 180 degrees, right? Quadrilateral, whether it's a rectangle or a square or a trapezoid or a rhombus, how many degrees is a rectangle or a quadrilateral? 360 degrees, okay? That you kind of have memorized. What happens though if it's a nonagon or it's some different shape and I got to find out how many degrees? That's what this does right here. This will help you find out how many degrees is in that shape. So that will be a really important formula that you have memorized. It's not hard. So now what we're going to do is we're going to use it. It says find the sum of the measures of the interior angles of a 15-gon. There's that n-gon that they were talking about. So what I'm going to do is I'm going to take that formula that I just had, n minus 2 times 180. Okay? I'm going to take out the n and I'm going to put in 15. Okay, then how would I go about solving it? What do I do?
15 minus 2.
Yeah, 15 minus 2, I get 13, right? Multiply it. I got 2,340 degrees. Is that what you got? Okay, good. That's how you show your work. That's how you do it on a test. Just like that. You do that, that's a 4. Way to go. Winner, winner, chicken dinner. Okay? All right, decagon. How many sides is a decagon? 10. Yep. So I'm going to grab that again. N minus 2 times 180. Plug in my 10. Subtract. I end up with how many degrees? How many degrees?
1,440.
Thank you. 1,440 degrees. Okay. Now notice that this problem doesn't ask you how many sides a decagon is. It's asking you for the interior angles, the sum of the interior angles of a decagon. So I may not say, how many sides does a decagon have? I will have it within the problem. So if you don't know how many sides a decagon has, are you able to do that problem correctly? No, you're going to have trouble. So it's hidden within the problems. Okay? Questions on those? Okay, let's move on. So now what we're going to do is we're going to look a little bit closer at this problem. It's asking me to find the measure of angle A. So essentially what I'm doing is I'm grabbing this figure, and this is A, and I need to find it. How many sides does this figure have? 4. So I need to find out how many degrees it is. Now, you know as well as I do, it's how many degrees? It's 360 because it's 4, but like why? So you need to prove it by using your formula. So you're going to grab your formula. It's going to be n minus 2 times 180, 4 minus 2 times 180, 2 times 180, and I get 360. So one thing you're going to learn that when you do your problems for me, I don't want just numbers pulled out of thin air and go, blah! Okay? I want you to like, how did you get that? Why is that true? Why are quadrilaterals always 360 degrees? Like, why? This is why. Someone came up with a formula. They're like, this formula will always work. And this is why every quadrilateral has 360 degrees in the interior angles. Okay? Now that I know that, what I'm going to do is I'm going to come back to this and help me out here. What does this little thing mean and that little thing mean? They're the same. And so what I'm going to do is I'm going to put an X there and an X down here so I can make them the same because their names themselves are unique. So angle A and angle B are unique. So I'm going to go ahead then and I'm going to go X plus 115 plus X plus 30 equals what does it equal? 360, the number that I just came up with. Now I'm going to tell you, if you did your math wrong and got 350 rather than 360 and you showed all your work and it was correct, that would totally be an A. Totally. Because you made a human mistake or you pressed the wrong button on your calculator and you understand the standard. So when you show your work and I can see what you did, you can definitely still get an A even though you mess up. Okay? Now, bring like terms together. So I get 2x plus thank you. 145 equals 360. 2x equals What do I get?
215.
Thank you, 215. Divide by 2, x gives me
Well, 107.5.
107.5, and it would be degrees, and I can also say this is the measure of angle A. So it answered my question. Notice how I'm using algebra. Set it up algebraically, combine my like terms, subtract and divide. Very common what students will do is rather than subtract 145, they'll add. Okay, I see that a lot, okay? So again, if you set it up and you show it like this and you add wrong, it's still in the A range. Okay. Questions? Am I going too fast? Okay. A regular polygon, okay? Couple of things with a regular polygon. I'm looking at the word regular. The first thing about a regular polygon is all sides, and I got a symbol there. What does that mean? Congruent. What does congruent mean? They're the same. They're the same length. So all the sides on them are congruent or the same length. The other thing you need to know about is that all angles are congruent. So again, you need to put this in your notes. This is a common mistake that students don't remember, was what the word regular means. So again, on your assessment, I won't necessarily say, define the following. I will say, of the regular nonagon, what is the measure of one of the angles? You have to know what regular means, you have to know what nonagon means, and you have to know how to find the interior angles of a nonagon. So it's loaded. Okay? Questions? Awesome. All right, let's keep going. All right, the sum of the measures of the, what type of angles? Exterior angles of a polygon, one at each vertex, is 360. So they're not the angles inside, they're the angles outside. This is what it means. So let's say I have a, I'm going to do a rectangle or quadrilateral. Okay. The exterior angles are the angles that are made when the sides are extended. So this would be like the first one, the second one, the third one, and the fourth one. It kind of looks like a pinwheel. It's not 180 degrees, it's a part of it. Okay, so I would take the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, and that equals 360 degrees. Okay, so essentially what happened is they just extended the side a little bit, and they're like, okay, this little piece right here, this is an extension. This is true not only for a quadrilateral, but for any shape. If it's a decagon, a nonagon, a pentagon, whatever, their exterior angles equal 360 degrees. All of them. So I could even go, well, hey, I could have a triangle here, and I could extend, okay? And this is angle 1 and 2 and 3. Same thing. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 360 degrees. So it works for any polygon. And you'll be using that on the test. Questions? Going too fast? No? Okay. All right. All right, so let's see here. Here's one. Find the measure of an interior angle of a regular nonagon. So this problem asks me for interior angle, regular, and nonagon. So interior angle, that angle is inside the figure, okay? Regular means, yes, sides and angles are congruent. Very good. Nonagon means 9 sides, 9 angles, right? Okay, so this is how we're going to go about it. So I am going to take n minus 2 times 180. Now you're going to have problems like this on your test. You're going to have problems tonight in your practice like this. So if you write this down, then you have something to go by to help you with those problems. So I'm going to take out n and I'm going to put in 9 because it's a nonagon. Okay, I'm going to go ahead and go 7 times 180. I like parentheses rather than a dot because the dots can sometimes be mistaken as a decimal. Okay, so 7 times 180 gives me,
1,260.
thank you, 1,260 degrees. Now that is the sum of all angles. That's what you found. If I wanted to find the measure of one of those angles, what would I do? Yes.
Divide by 9.
Very good. So I take 1,260, divide it by 9. I end up with 140 degrees. And that is one angle. All of them are 140 degrees because it's a regular nonagon. If it wasn't a regular nonagon, I couldn't find out one angle. I could find the sum of all of them, but not one. So that's the interior. Questions? Okay. Now you're going to notice off to the side, I had, there it is, exterior. Do you see that? Okay. If I have a nonagon, we had 9 sides. How many degrees did we say the exterior angles of a nonagon are? It's 360. So I take 360 and I divide it by, and what do I get? You had it. 40. Very good. 40 degrees. So this is one exterior angle is 40 degrees. So if you think about a nonagon and it's got those little things that come off like a pinwheel, one of those exterior angles is 40 degrees. That happens with a regular nonagon. So that is a sample of a test question that you could have. Notice how it's loaded. Interior, exterior, regular, nonagon. You have to know the number for exterior, 360. You have to know the formula for the interior. Questions? All right, a couple of problems now, just so that you get the idea of how to do this. So this asks me to find x. Is x an interior angle or an exterior angle? It's interior. How many sides does this figure have? It has 7. So I'm going to go ahead and I'm going to grab that n minus 2 times 180. I'm going to plug in the 7 minus 2 times 180. 5 times 180. I get how many degrees? Thank you, 900. So if I took all of those angles inside that shape, it would give me 900 degrees. So how would I go about finding what x is? What do I do?
We would add them all up, equal to 90, and solve for x.
Very good. Yeah, absolutely. So I'm going to pick one of the vertices. I'm going to start with 20x, and I'm going to go clockwise. So I'm going to go 20x plus 20x plus 27x plus 135 plus 130 plus 130 plus 170 equals 900. So that's how you'd set it up. Now, some kids will say, Mrs. Medvick, can I go 2 times 20x and 2 times 130? Absolutely. You could definitely do that. That's not a problem. Okay, I'm going to combine my like terms. So how many x's do I have? Thank you. 67x plus What do you got? What do we got? I got 565. Is that what you got?
Yeah.
Okay. Yeah, now I got it. Equals. What does it equal? 900. That's what we found, right? If you got the 900 wrong and you added wrong and you put 890, your answer is wrong. It's still in the A range if you show your work. Does that make sense? Yeah, I'm able to see what you did wrong. All right, now we do what? Subtract. So 67x gives me, I got 335. Is that what you got? Okay, and then x gives me 5. Label?
Units.
What type of unit?
Degrees.
It's going to be degrees. Very good. Yep. I tend to, if it's measure of an angle, it's always degrees. If it's side measure, I do units or centimeters, something like that. Okay, very good. All right, last one. I know, you're just loving this. What type of angles are these? Exterior. Their sum is 360. So even though it's a triangle we added exterior, they equaled 360. Even though we added the quadrilateral together, there was 360. And this is a couple more. Exactly. And they're still 360. Okay. So I'm going to pick a angle measure. I'm going to pick 62. So I'm going to go 62 plus x plus 42 plus 48 plus 52 plus x plus 60 plus 20 equals 360. And that's where students kind of like, really? 360? Yeah. You would think it'd be more because it's a bigger shape, and it's not. So bring my x's together. How many do I have? 2. Yeah, that's 2. And then I got 284. Is that what you got?
Yep.
Good. Equals 360. 2x equals. Thank you. 76. X is 38 degrees because you divide. Okay? So I am modeling how you need to do these on an assessment or a homework quiz or on your practice. All right? Questions? All right. Let me show you how we get their assignment.